Okay, let's dive right into this explainer. Today, we're taking a look at the absolutely incredible physical forces that are actively shaping our only home. We're going to peek behind the curtain at the vast hidden mechanisms keeping this whole planet running. And here's the crazy part. We're going to look at some staggering new data showing how the fundamental physics of Earth are literally shifting right beneath our feet.
I mean, consider this mind-bending mystery for a second. How on earth are our everyday actions physically altering time itself? Right now, every single day, without you or me even noticing, the Earth is taking just a little bit longer to complete its rotation. Now sure, we're talking about fractions of a millisecond here, but the sheer physical force required to actually produce that kind of shift, it's almost incomprehensibly massive. It's a story that takes us from the deep history of our solar system all the way to the ultra-precise GPS networks we all rely on today.
So, part 1, what makes Earth unique?
To really wrap our heads around how our planet's spin is changing, we first need to appreciate what makes Earth so incredibly rare in the first place. Scientists have found nearly 5,000 exoplanets out there in the dark, but we literally haven't found anything quite like our own. It's just this wild combination of factors that have to go perfectly right for a planet to actually support life. We're sitting right in that ideal Goldilocks distance from the sun, right? Not too hot, not too cold. We've got Jupiter acting like this massive cosmic vacuum cleaner, using its immense gravity to sweep up dangerous planet-killing debris. Plus, we have a relatively large moon that actually stabilizes our rotation so we don't have these chaotic polar shifts. And crucially, we have liquid water covering about 70% of our surface, which ties directly into the next incredibly dynamic feature of our world.
Just look at the stark difference between Earth and a planet like Mars, for instance. While Mars basically has this dead, rigid crust, Earth is totally alive with active plate tectonics. And why is that? Well, it turns out water doesn't just support biology on the surface. It literally lubricates the massive tectonic plates sliding past each other deep underground. This constant recycling of the Earth's crust builds mountain ranges, triggers earthquakes, and maybe most importantly, it helps regulate our global temperatures over millions of years.
Which brings us to Section 2, our invisible magnetic shield.
Now, if we zoom inward, past that crust, and way down into the deep interior of the planet, we find the unseen, heavy-duty mechanics protecting our fragile atmosphere. Because honestly, without this mechanism, those oceans we just talked about would have boiled away into space eons ago. Deep within the Earth is the geodynamo. Imagine this immense, churning internal engine made of swirling liquid metals. All that movement creates electric currents, which in turn generate our planet's powerful magnetic field. It's essentially a spectacular, planetary-scale force field extending far out into space, acting like a shield to deflect the highly charged, destructive particles carried by the solar wind. So it's really this unseen, swirling core that keeps our whole water-rich surface safe and intact.
Moving into Section 3, altering the planet's spin.
Okay, so we've established the baseline here, a stable, water-rich, tectonically active planet shielded by a magnetic field and stabilized by a big moon. But here's where it gets crazy. Shocking new research from the University of Vienna and ETH Zurich shows that human-driven climate change is physically impacting the planet's rotation on a level we haven't seen in 3.6 million years of geological history. Now, the key to understanding this is how shifting mass actually changes rotation. Think of a spinning figure skater, right? When they pull their arms in tight, they spin incredibly fast. But the second they extend their arms outward, their mass spreads out and they immediately slow down. Well, Earth is doing the exact same thing right now. As polar ice sheets melt, all that water that was locked up tight at the poles flows into the oceans and spreads outward toward the equator. So the planet physically bulges at its waistline. And just like that skater extending their arms, our planet's spin actually slows down. Right now, the rate of this climate-driven day lengthening is 1.33 milliseconds per century. And yeah, I know exactly what you're thinking. A fraction of a millisecond? That sounds completely trivial. You are definitely never going to notice that on your watch. But here's the thing. In the realm of planetary physics, to alter the momentum of an entire world by even a fraction of a millisecond, that requires an almost incomprehensible application of force. To really get it, you have to contrast that tiny little fraction of time with this absolutely massive number. 1 trillion. That represents 1,000 gigatons of mass physically moving from the poles to the oceans. That is the staggering redistribution of physical weight required on the surface of the Earth to cause that 1.33 millisecond delay. 1 trillion tons. Let's try to visualize what 1,000 gigatons actually looks like in the real world, using an awesome example from the researchers. Imagine taking all that melting ice and packing it into a single solid cube and dropping it right over New York City. That single block of ice would be 10 kilometers high. I mean, that would literally tower over Mount Everest. Releasing that much water toward the equator unleashes a shift in rotational energy that is equivalent to a magnitude 9.0 earthquake. Not in the sense of destructive shaking, but in sheer planetary-scale kinetic force. It's just wild.
And that brings us to a pretty stunning projection. So historically, the absolute biggest driver of changes in our day length has always been the gravitational pull of the moon, gently tugging at our oceans over time. But researchers point out that if current emission trends continue, the human influence of climate-driven mass redistribution is actually going to outpace even the moon by the year 2100. It will literally become the single biggest driver of Earth's spin shift. And this isn't just trivia, it actually matters today, because that tiny millisecond shift is absolutely critical for the ultra-precise timing we need for spacecraft navigation and the global GPS networks that basically run our entire modern world.
Let's step back for section 4, the pale blue dot.
Let's zoom all the way out from the geophysics for a second to really reflect on the philosophical weight of these monumental physical changes. Back in 1990, the Voyager 1 space probe was a mind-boggling 6 billion kilometers away when it turned its camera back toward the inner solar system to take a picture. Look at that tiny little pixel caught in a band of scattered sunlight. That is Earth. It is such a powerful reminder that this massive, forceful world of ours is, out in the cosmic dark, really just a single, tiny, incredibly vulnerable pixel.
The great Carl Sagan famously wrote about this very image, saying, "Look again at that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives, on a mote of dust suspended in a sunbeam." The contrast there is just breathtaking, isn't it? We literally just spent this explainer discussing the cold, immense forces of planetary physics, the geodynamo, the shifting of 1 trillion tons of ice. And yet here is the intimate vulnerability of our entire human existence, perfectly captured in a single speck of light.
The sheer scale of what we are observing right now is just staggering. The fact that the actions of the inhabitants on this tiny pixel can melt enough ice to rival the gravitational pull of the moon and literally slow down the rotation of the planet itself, well, that is a testament to our unprecedented power. But with that astonishing power to reshape the physical mechanics of the Earth comes an equal and profound responsibility to preserve and protect it.
So, I want to leave you with this final thought to ponder. As the data clearly shows, we are altering the very spin of our world, literally moving mountains of water and shifting the physics of time. What legacy will we choose to leave on the only home we've ever known? Thank you so much for exploring the incredible science of our pale blue dot with me.